So far it's not working.
All right, we're doing take 2 here on the clickers. So if you have the physical clicker, it should be channel 44. If you have the app, this should be the session ID 878596. Also here. So go ahead and give it a shot. Anybody struggling with this? Yes.
If we are cheap and we don't want to get a clicker or the app,
Yes.
can we? This is just for extra credit. Like we can
Correct.
still
Yeah.
pass without it. Okay.
Yep.
I'm really cheap.
Aren't you computer science?
No.
Aren't you computer science?
I'm computer
Can't you
science.
figure out a way to jury rig this? I have no problems with you figuring it out if you want to do so. All right, there are more than 27 people in here. Show of hands, who knows they have not registered a response yet? Okay. What's that? The channel is 44. So if you have the physical clicker you buy from the bookstore, it's 44. If you have the app, it's 878596. All right, so there's 28. I'm going to treat this like a bag of popcorn. If we go like 5 seconds without a registered response, we're going to shut it down. I want to burn the popcorn. All right, that seems to be working reasonably well. Now there's going to be a contingent of y'all who think you voted, who would not have gotten credit for the session if this was an actual extra credit session, and that's because you have not gone and registered your actual clicker. So make sure you're going in through this turning point and actually register your clicker. Then it will link up to this class and you'll be able to get credit for that. Any questions about that? Cool. Cool. All right. So, let me get started here. Did power go out across campus?
Yes.
Anybody know why? Why? Is that just the Tennessee Valley Authority? Oh, good. Awesome. How's everybody's weekend? Long weekend? Anybody do anything particularly fun? Yeah?
I flew to Virginia for one day
Why?
for my job orientation.
That's awesome. Can you say who you're working for if it's in Virginia?
The Aerospace Corporation.
Nice. That's awesome. What part of Virginia?
Chantilly.
Nice. It's just near where I grew up. Anybody else? Anybody watch the UFC fights? I did not know you could break somebody's nose by throwing a shoulder, but if that doesn't make any sense to y'all, go look at the videos.
Maybe he was really dedicated to faking his injury.
Could be. All right, what did we learn last time? I'm sorry? Okay, so what is a case study? Give it a shot.
Like experiments with what's going on. Example, I kind of think of it as if someone was looking in right now and like watching what we were doing. It's like a case study because you're studying
So that would be more of a naturalistic observation. Somebody would just like watching the class without us knowing about it. Can you help out with case study?
You sort of look at a singular individual in great depth and like very specific details about that one person.
Yeah, so give me an example of when we would want to use a case study.
If one singular person, did something bad, you have to look at like their past scenarios to like why they would have done this certain thing. So you go into great detail about every little thing they've done.
Yeah, I mean, you can think about this essentially as what the media does anytime something awful happens. They try to figure out, okay, what was the precipitating event that led this person to do whatever that heinous act was? Doesn't always have to be bad, but that's frequently where you see it a lot. Yeah?
Which answer questions you want to answer?
Whichever.
About the case study. Okay.
Yeah.
An example of a case study is looking at the history of like some medical history.
Mhm.
See if they have like a history of heart disease, something like that.
Yeah. All right, so new rule in this class, if you participate in this, not just picking on you, you have to speak up because I'm an old man and I can barely hear, and I don't want to have to do this too early in the actual semester. But yes, so medical histories are a great thing to also go through, especially if it's a particularly rare event or a rare disease. Drilling down into the history to figure out potentially what sort of environmental causes could there have been. Did something the mother do potentially contribute to it? But then also, what can we learn about this disease based off of this individual? Yeah?
Is it, aren't people doing that right now with the disease that came about in China?
I don't know what disease came about in China.
No, it's like a kind of an offshoot of the Black Plague.
Oh, that's not good.
Yeah.
Very possibly. I know nothing about it, so that's very possible. All right, what else did we learn? Yeah? I'm sorry?
Hello. So we learned about surveys.
Okay. Yep. And so when would you use a survey?
If we're looking at like a larger population, and we just looking at a simple question, yes or no question.
Yep. Yeah, so if you're wanting to get a larger population, if you want to get a more diverse population than you would get in a college, what else did we learn? Yeah.
About placebo and how it's used in medical studies.
Okay, and what is a placebo?
It's a sugar pill that's used to see how someone reacts to. What's that? They use it in medical studies to see if they have like the same effect as when they use medicine.
Mm-hmm. So why would we use a placebo? Why don't we just use nothing?
See if the medicine actually works and it's not just something psychological.
Yeah, so maybe participating in the study or thinking there's a potential upside for the medicine can lead to an actual benefit there. What else did we learn? Yes?
Talk about like different types of variables, like independent and independent.
Yeah. So what is an independent variable?
It's like what you change in the study.
Yeah. So speak up for everybody. What is an independent variable?
It's what you change in a study.
Okay. And what is a confounding variable?
It's like what you didn't account for, like something that could be influencing it, but we weren't aware of it at the time.
Yeah. So can somebody else give me an example of a confounding variable and maybe a correlation? Yeah.
When you're talking about the ice cream sales and the shark attacks, like the heat would be the confounding variable, like the temperature outside, because it causes both to increase, but the shark attacks and the ice cream aren't directly affecting each other.
Yeah. Great. All right, give me one more thing we learned last time.
Hypothesis.
Okay. And what are the marks of a good hypothesis? Okay, falsifiable. What else?
To be reproduced,
It can be what?
be reproduced or experimented.
Yeah. Yeah, so you can experiment with it. You can actually run tests on it. What else? Specific. Yes. Yeah, you don't want some broad, overarching hypothesis, in part because that's going to lead to poor operationalization. And what is operationalization again? Yeah.
You're sort of working definitions to help you be able to like directly measure your variables.
Exactly. So if I say I want to know what effects sleep has on memory, what do I mean by memory? Do I mean semantic memory? Do I mean visual memory? Do I mean long-term or short-term memory? What do I mean by sleep? Do I mean REM sleep? Do I mean hours in the bed? Etc. Great. All right. Any questions about what we covered last time? Ruby. Here's possibly the most disturbing fun fact you're going to get all semester. Bones found at Seymour Island indicate that 37 to 40 million years ago, penguins stood at a formidable 6 feet tall and weighed 250 pounds.
That's awesome.
Yeah. How about that? Waddling dune buckets. Yep.
Those are giant icebergs.
They better have been. Yeah. All right. So these were on the slides from last time, but we never actually got to them because I ramble too much and like to hear myself talk. And so we're going to go over these really quick, and then we're going to get on to what we're actually supposed to be talking about today. And so when we talk about the scientific method, we talk about data collection, we talk about analyses, we have kind of three specific measures of central tendency, as we call them. Mean, median, and mode. And it's important to recognize that each of these are essentially considered an average. So when you're doing scientific research, you never want to say an average of 37 years for participants, an average age. You would want to say something like a mean age of 37 years. Now, mean is what you think of when you think of average specifically. It's the sum of the observations divided by the number of the observations, rather. So for today, I said, what is the average age in this room? This is almost certainly how you would have gone about getting it, of adding up everybody's age and then dividing by the number of people in here. Median is the middle number when the numbers are arranged from smallest to largest. And that is an important distinction. You want to arrange the numbers first before you find that median. So if we have this same data set from before, we rearrange it in order. Now our median is 8. If you have an even amount of numbers, just take the mean of the middle two. So let's pretend we didn't have that 10. What would our mean be for just these first 6 numbers? Or excuse me, our median.
7.57.
Yeah, 7.5. You're just taking the mean of those middle two numbers. So when might you want to use the median rather than the mean?
When you arranged in order.
Well, so you can always arrange them in order, but think about the data. What type of data would you want to be using the median on?
There's very large outliers that speed the result.
Yeah, exactly. So my favorite example is if you look at the mean salary for UNC graduates, I think in geology or something like that. The mean salary in the 1990s was something like $150,000. And it's because Michael Jordan was a UNC geology major. Clearly, he's skewing the data in that capacity. And so, in that case, the mean is not really all that representative of what the actual average, so to speak, salary would be. And so, in those cases where you have those extreme outliers, using the median helps guard against that. And then mode is the number which occurs most often in the sequence of numbers. So if we look at that same distribution of numbers, 4, 5, 7, 9, and 10 all occur once, 8 occurs twice. And so mode would be the, or excuse me, 8 would be the mode. You can have more than one mode. You can have one mode, you can have no modes. If you have two modes, we call it a bimodal distribution. So when might you want to use the mode instead of the median or the mean? Yeah, so when a number occurs a lot, and so let's say I'm trying to think of a good concrete example. Say for example, you wanted to be buying a computer and you've broken it up into ranges and you've got, under $500, $500 to $1,000, and then $1,000 more for a computer. Obviously, you can find examples under $500. You can find examples over $1,000. But in this case, the mode of that 500 to 1,000 is going to give you the best representation for what you should expect to budget for an actual computer. Because again, you can have these high outliers that are skewing the data, and there can be a lot of high-end outliers. But maybe you just want to know, okay, what is kind of what I should expect is the average amount of money to spend on a computer. And so there you've got that representation of from 500 to 1,000. And so we have those measures of central tendency, the mean, median, and mode. But then we can also think about variation. And so the variation is just how spread out are the data. An important distinction, especially if you want to sound smart, data's plural. Does anybody know what the singular version of data is? Datum, yes.
Wait, what?
Nope, datum is a single, data is plural. Now, if you're writing for the APA, the American Psychological Association, in that format, they just decided to allow people to use data as a singular, even though it is a plural word. Which goes to show if you do things wrong for long enough, society conforms to you. But yeah, feel free to say, the datum instead of the data point moving forward. Yes?
The thing is, if you were to write data or data down, nobody can really tell if it's singular or plural without the context.
I'm sorry, datum, D-A-T-U-M. Yes. Yeah, you're exactly right. If it's just all in the eye of the beholder, you're screwed in that context. So data with the same mean can have very different variations or variability. Right? And so you see, if we look at these data, the mean is probably somewhere about 5.5. But this population is substantially different in type than this population. So who can think of a data set that may have really small variability? Values are all really close together.
The age of freshman at UAH.
Yeah, the age of freshmen at UAH. There are going to be a couple adult learners and a couple wonderkin who are 14. But for the most part, it's going to hover right about at that 17 to 19 range. Who can think of an example of something with a large variability or variation?
Age of everybody on campus.
Yeah, the age of everybody on campus. So you have some folks who are here just to take a class. Maybe they're working in Research Park. And then you also have some high school students who come and take a college class while they're still in high school. And so you can have a large variability in there. Professors? Yes. Some look like 12-year-olds. Some have grandchildren who are 12 years old. All right. So you've got the following data set. Quickly figure out what is the mean, the median, and the mode. And then think critically, if I added three more numbers between 1 and 10, would the variance be greater or smaller than if I added one number between 11 and 20? Bless you. Like somebody played an oboe over there.
That actually sounds like high C.
You're better than I am.
Relative pitch, so.
All right, so who can tell me what the mean is? Yeah. 5.44444. I didn't actually do it, so I don't know if that's right. Does anybody have something else? That's right? Okay, perfect. What is the median? I don't know. I also haven't done it. 6? Is that what we have? 5.5? Math is not usually a democratic activity, but we're going to just go with the people who said 5.5 because there are more of them. And then mode. 3 and 8. Yes, bimodal. I did do that one. All right, so what happens? If I add 3 more numbers between 1 and 10, would the variance be greater or smaller than if I added one number between 11 and 20?
One number between 11 and 20.
Would be what? Larger or
Would
smaller?
be larger variance.
Yes. Yeah. So if I add a number outside of that pre-existing range of 1 to 10, the variance, or the variability, variation, is increased. Questions about mean, median, and mode?
Can you say that last one?
Yeah. So if I add a number outside of this pre-existing range here from 1 to 10, it's going to increase the variation, the variability, over what you would have if you add 3 numbers between that pre-existing.
So the answer is smaller.
In this case, it would be smaller, yes. Questions? All pretty straightforward? Cool. This is important for you all to know. I realize most of you all have probably already seen this many times before, but anytime you're going through and reading articles, it makes sense to question what type of central tendency measure they should be using. It also shows you, remember I said a couple times that data don't lie, people lie about data. It becomes really easy for the geology department at UNC to say, come study geology, our majors are making an average of $150,000 a year. That's kind of a fib. All right. So in order for us to generalize results to society at large, we need two things. A representative sample that is selected randomly. So I think, as I said before, there still may be no theoretical reason that one population varies between another population. So again, we don't really have any reason to believe that your retinas in the back of your eye, function any differently if they're healthy and normal than do those who are, 80 and above. But it still sometimes benefits you to try to get a representative sample if possible. So the representativeness just refers to, okay, who are you trying to extrapolate to? Try to get a population that looks like them. If I wanted to study malnourishment in the state of Alabama, probably doesn't make sense to pull a sample of college students. It may make sense to go to, some of the rural areas in addition to places like Huntsville. You also want to randomly select your sample. Right? If I said, I want to know, on average, what school is more athletic, UAH or UAB, and then I select all the student athletes at UAH, and then, sorry for picking on computer science, I pick all the computer science students at UAB, and evaluate their athleticism, that's not really a random sample. That is very specifically targeted towards a specific hypothesis. So by randomly sampling, by picking out people without any sort of preordained agenda, there will be some variations, but what you're hoping is that those variations wash out between groups because I'm just randomly pulling. And by and large, the less variable observations we have, the better our ability to detect whatever that true score is. Now, there are a couple sources of variability, and we won't go into all of that. That's for your statistics classes. But if we don't have any reason to believe that there is large variation in a population, if we're observing large variation, that means the measure we're using is bad. Right? And so we can think about a broken scale. Say I'm getting ready to compete in a jiu-jitsu tournament and I need to come in at 170 pounds. I want a scale that's going to be consistent every time. I want to be able to step on it, see 170, step off it, step back on, see 170. I don't want a scale that's going to tell me 130 pounds, and then 240, and then 165, and then 190. Even if it all averages out to that true score, that variability in the actual scale itself is preventing us from being able to have confidence in that true score. And then we talked last time about the law of small numbers, the law of large numbers. Who can tell me what the law of small numbers is?
When you have small numbers, then you're going to have extremes.
I'm sorry, one more time?
When you have small numbers, you're going to have extremes.
Small numbers like 1, 2, and 3? Is that what you're talking about?
A small population.
Yeah, small population, you're more likely to have extremes. Right? So again, think about the example of flipping a coin. Are you more likely to get 100% heads if you flip the coin twice, or if you flip the coin 200 times? Twice, right? And so again, the example we use is, that's why you see the highest rates of cancer in small populations or small towns. It tends to be the case that we then, as a nation, say, oh my God, what's happening to their water supply, or what's happening to their food, or are there any environmental toxins from the plant around? And it could be the case, but it also just could be the fact that as a small town, they're more susceptible to these major swings in percentages. And so there's also a whole component of ethics. Whether or not you're dealing with human subjects, but everybody in psychology is dealing with human subjects, we have three main components that we're concerned with: autonomy, beneficence, and justice. So for autonomy, we're just suggesting that we need to protect the autonomy of all people and treat them with the courtesy, respect, and allowing for informed consent. So what is informed consent? Yeah.
It's when somebody like consents to something knowing what's going on, not just, yeah, okay, and then they have no idea what's going on.
Yeah, exactly. So if I'm running a study, I need to tell you what that study's about before you agree to participate in it. I can't say, yeah, this is a study to see how happy puppies are going to make you, and then it turns out I want to remove 6 of your teeth and see what sort of effects your diet have on your teeth. You have to be informed before you actually give consent. There are exceptions. So you can either waive informed consent if it's very not risky. So if it's something like, hey, can you just answer this quick questionnaire about, what your thoughts are on UAH? But I have to get approval to waive that informed consent. There are also certain circumstances where you can be intentionally deceived. So maybe I don't want you to know what the purpose of the study is, because that ruins the purpose of the study. But again, in those cases, I have to go through what we call an institutional review board and get approval to deceive you. And all the precautions have to be in place to make sure that you're not being harmed. You're not allowed to be deceived if it's something that is a high-risk study, right? You have to have the knowledge of what you're going to be asked to do or what's going to be done to you in exchange for your participation. Beneficence is the philosophy of do no harm while maximizing benefits for the research project and minimizing risk to the subjects. So what that's saying is, we want to reduce any potential risk to y'all as participants while increasing the benefit to society, to research as a whole. The flip side of that is we don't want to be doing really risky studies that aren't going to tell us much. Right? We don't want to be seeing if we can teach people to juggle knives by having them juggle knives right off the bat before they know how to juggle, because that's not really going to tell us much and is a high-risk proposition. Now, the final component of it is justice. So ensuring reasonable, non-exploitative, and well-considered procedures that are administered fairly, the fair distribution of costs and benefits to potential research subjects, and I don't know where the rest of that sentence went, but that they're equally distributed. So there are several protected populations when considering doing research. Does anybody know what those protected populations would be? Children, that's one. I heard some muttering, but I didn't hear anything. Yeah.
Maybe elderly?
So not so much the elderly. Yeah, disabled. So provided that the elderly have all their mental faculties, like they're still able to reason through things, they're not a protected population. But the disabled, most specifically the cognitively disabled, prisoners, because they can be coerced into participation. We want to make sure that they're not participating in a research study because they perceive there to be an additional benefit that maybe they can get in the good graces of the guards by doing so. And military populations for similar reasons. You also want to make sure you're not targeting any one specific demographic with your research. There are historical studies and examples wherein specific demographics have been targeted in very inappropriate ways for the research. Now, it violated other examples, but one would be the Tuskegee syphilis study. We won't go over all the details there, but the history of psychology is replete with examples wherein we didn't abide by these sorts of rules, and that's why safety procedures have been put in place, like the Institutional Review Board. So now, anytime I want to run a study on y'all, I have to go get approval from this board made up of researchers, but also community members who are making sure I'm abiding by each of these three components. So research using human subjects needs to be ethical in general. So like we said, you need to have informed consent. You need to protect participants from greater than usual harm or discomfort. Keep information about participants confidential. So if y'all participate in a study, you'll see something about confidentiality on the informed consent form. And all that's saying is the policy of the labs, but it's pretty boilerplate in the sense that if you participate, we're going to anonymize your data so nobody can ever track down that data. And we're going to lock that data up so nobody can access that data, let alone trace it back to you. And then fully debrief. So you have to be told after the fact, what was the purpose of the study, why we do the study, what are we expecting we're going to find, etc. So all of y'all will be participating in studies, or at least you have the option to participate in studies. You also have the option to do the non-study route for the credit. But a couple of rights, just so you all know them when you go into the study. You can leave at any time. So if you go to the study and you feel uncomfortable for any reason, you don't have to participate. You can just say, I'm here, I'd like my credit, but I feel uncomfortable and I'm going to leave. And they're not allowed to pressure you, they're not allowed to persuade you, not allowed to say, oh, please stick around. If they do, let us know. You have the right not to be coerced. So they can't hold your participation over your head. So if you're in the middle of the study, and for whatever reason you feel like you need to leave, you can leave, and they can't say, fine, but I'm not going to give you credit. I'm trying to get you to stay. You have a right to know what the purpose of the study is, so again, that falls into the informed consent. There are very few studies that will ever deceive you. But if they do, that's part of the debriefing process where they'll tell you, actually, we lied to you at the beginning. The real purpose of the study is this. And finally, again, you have the right to receive the appropriate compensation for participating in the study, even if you decide to withdraw. Questions about that? Pretty straightforward. Kind of boring. Cool. Also, this should go without saying, but people like me and the grad students, our livelihoods depend on the data, so don't show up like drunk or high. I've had this issue before where participants literally show up drunk and like fall out of their chair. It's not endearing, it's not fun to deal with it, so just wait to get drunk until like the sun's gone down or something. Unless you're underage and don't get drunk. What's that?
Those are called extreme variables.
Yeah, there's a confounding extraneous variable there. All right, now 40 minutes into the lecture, we're getting to what we're supposed to be getting to today. Nature, nurture, and human diversity. So genes are essentially the master code for everything in your body. And every cell is carrying this sort of master code. So we find these genes, this genetic makeup, the code there, and 23 pairs of chromosomes in the cell's nucleus. And you sometimes hear about disorders that are, or syndromes that specifically target the pairs of chromosomes. So Down syndrome is trichromosome 23, I think? 21? 21. And then you have things like Williams syndrome, which is where I think one of the 7th pair of chromosomes is missing. Just learned about Williams syndrome. This is a tangent. You're not going to have to know this for the test. But it's obviously debilitating. But it makes people like ultra friendly. Like they want to just go up and give strangers hugs. They completely engage in kind of this release of inhibition and happiness. It's almost like that really friendly drunk friend you may have of going out and really putting themselves out for those interactions. Still debilitating, but it's kind of endearing. So as you would expect, half your genetic makeup is from your mom, half from your dad. And it's the manifestation of those genes that makes you who you are. By manifestation, I mean it's the interaction between the genes and your environment. And so I'll show a video here in a little bit, provided we have time, about this interaction between genes and your environment, where your genes can actually carry memories, for lack of a better term, between generations. And so the manifestation of those genes can be turned on, turned off, depending on the gene, but it can also be graded. As we discussed before, genes themselves aren't predicting much. Genes alone, rather, are not predicting much. It's that interaction between the genes and the environment, so a mix of nature and nurture. So we talked about twin studies. Have two different types of twins, right? Identical and fraternal. Identical are monozygotic. So they come from the same fertilized egg. And then fraternal are dizygotic, which means it was two separate eggs that were fertilized at the same time. So while fraternal twins are no more alike than just normal siblings, identical twins share the exact same DNA makeup. Does anybody have an identical twin in here? Oh, darn. One of these years I'm going to have an identical twin. I'm going to ask so many questions. Yeah?
I was just going to ask, do you know if identical fraternal twins have anything to do with like their appearances?
If identical twins have anything to do with appearances?
So fraternal, like, will identical always look the same, something like that?
So, I mean, it depends, right? So again, your genes are leading to the certain manifestations, but it's the interaction with the environment. Identical twins are always going to be the ones that look almost identical. But I've had a few friends who are identical twins who you can start to see differences and variations in them. So even though they share the exact same genetic makeup, there are still physical differences at times. But they are much more likely to be, at least appear, identical. So, yeah?
I actually know a set of twins who were about 4 inches in height difference because one was a picky eater as a kid.
That's fascinating.
Yeah.
Identical?
Yeah, they were identical. And like they had even like done tests and stuff because they thought they were, and then they turned out looking pretty different. And it turns out that there was just a lot of differences in like what they ate as kids.
That's amazing for so many reasons. One is the picky eater thing, right? So it's clear that picky eating is not just fully genetic. There's some different manifestation there. And then what that meant for their height after the, yeah, that's really interesting. Yeah?
I went to high school with a set of twins, and genetically they're fraternal, but if you look at them, you can't tell them apart. Because they had it tested. and
Yeah.
If you look at them, you'll think they're identical. They're Kim and Emily. You can't tell them apart.
That's really interesting. Yeah, so I mean, you can have fraternal twins that look almost identical, but it's no more likely than you would have with siblings. I've been talking about this in one of my other classes. Have we talked about twin studies in here? Am I making this up? We have not talked about twin
What
studies?
was their reading? Like in the
Okay.
chapter we've done?
So I'm going to stop referring to as we talked about. Everything's blurring together. So what can twin studies tell us and how do we use them? Well, if identical twins are more likely than fraternal twins to both have, for example, autism spectrum, what does that tell us?
That has more to do with genetic makeup and environment.
Yeah, that there's at least some genetic component to, in this case, autism spectrum. If, on the other hand, identical twins are no more likely than fraternal twins to have autism spectrum, what does that tell us?
Genetics isn't affected that much.
Yeah. Yeah, it's possible there's a small genetic effect, but that there may be mostly explained by an environmental. So for a while there, I don't know if it still is, but there used to be a convention for identical twins. And so psychologists would go to the convention and set up booths and start trying to collect all the data on these folks. The particularly interesting ones are those who were separated at birth, right? There are some examples of identical twins who were given up for adoption right after birth and were separated into two different families, right? And then reconvene as adults. But you can see, okay, what are the different components of their life that are identical? What are different? And that allows us to start saying, okay, there appears to be a substantial genetic contribution to whatever this is, to taste, for example. Or these things seem to be more environmental. And if you want to go down a rabbit hole, there are exposés on YouTube of identical twins that were separated at birth and then find themselves reconnecting as adults, and some of the freaky coincidences that they have. Now, some of them I think are just by chance, but there was a set of triplets, and I can't remember all the details, but they were split at birth, and then they found themselves all going to the same college. They all wound up, I think, majoring in something similar, and then all married women by the same name, chose very similar professions. So again, this seems to suggest that there is a fair component of, the oboe's back, fair component of genetics at hand with everyday life. So again, being twins, you share a genetic code. That's going to allow us to ascertain the nature component. Being separated means they have different environments, and that's that nurture. And so there's actually a fair debate in the scientific community about whether parenting really even matters, right? Whether your success is almost preordained by your genetic makeup. Now, obviously that's not the case, because there are interactions with the environment. You have to make sure you're stimulated to the right amount, but you can have substantial contributions of genetic code with things that you may think are fairly free will. Turning up the volume.
Scott Kelly will try something no American has ever done before. This spring, he will leave for a mission and spend a year in space. His twin is former astronaut Mark Kelly. Now, Mark's role happens here on Earth. Don Dare was at the Johnson Space Center in Houston when he spoke with his brothers. Don, good morning.
Good morning. This is the International Space Station mock-up where the astronauts do their actual training. There are 4.5 million twins living in the U.S., but there's actually only one pair of identical twin astronauts, Scott and Mark Kelly. Now, as NASA looks towards the possibility of a 3-year-long round trip to Mars sometime in the future, the Kelly brothers have become crucial into understanding what the long-term effects of living in zero gravity are for the human body.
I'm the type of person that likes challenges.
Scott Kelly will be conducting numerous experiments with a rotating crew of astronauts, but his primary mission during this arduous year-long assignment,
So the holes here for your arms.
is to study the challenges long-term exposure to the extremes of space have on humans.
Do you think that the human body and the human mind are capable of long trips in space right now? That we do
really well in space missions, but it's the physiological, the medical stuff, the stuff like radiation, muscle, bone mass, and muscle mass and density. It's those things that we need to figure out.
Mark, Scott's twin brother, will also take part in figuring it out, but back here on Earth.
Yeah, we need the laboratory on that. I'm in the MRI machine tomorrow for 4 hours.
Having Mark as a control subject is very fortunate, not only because we're twins, but he's also a former astronaut. NASA has data on him going back to 1995.
Genetically, the brothers are almost identical, so scientists will be able to measure how Scott and Mark change physically and emotionally as months pass. The human body was made for living in gravity. Strange things happen to us when we spend long periods of time without it. Bones get fragile, the heart weakens, eyes lose their shape. But that never deterred the former Navy test pilots from dreaming of becoming astronauts.
So this has actually been completed already. I can't remember which one actually went up to space, but was up there for a year. They came back and they've been running tests and have been making the data public as part of that research effort. And so you can see, as they have this kind of divergence, what things are attributable to the effects of space, right? You wouldn't want to just pick two people who were physically identical, right? Not genetically identical, but physically identical, and then have them go into space, because the genetics can affect their reactions to different stressors, can affect the deterioration effects over time as they get older. A year is obviously a long time for the human body. And so having identical twins as the test subjects allow them to study with a lot greater rigor, scientific rigor, what the overall effects would be of a long-term Mars mission. So, I'm trying to remember who actually said this quote when I put it in here. But getting to Mars requires multiple systems. In NASA, to be working at once, the system that's most fragile and destructible of all, however, is the human body. It's the one we didn't invent. It's the one we're stuck with. Right? And so this is the fascinating part of psychology. As you think about these technological advances, so much of the limitation is the human body, whether it's mental limitations, thinking you can't do something, right? The whole idea of spending a year in a little capsule in space sounds awful to me. And so mastering kind of the cognitive aspects of that. But also the physical aspects, right? And so you think about these new generation of fighter jets, the human is the limiting factor. They can pull G's substantially greater than the human pilots can sustain, but it's the human that needs to be studied and needs to be worked with in order to utilize a lot of these technologies. So take some time talking to your table. What are the issues associated with doing twin studies? What concerns might we have about drawing conclusions from them? So talk with your neighbor, and then we'll reconvene. You can go find your neighbor. No, I know the answers.
Hey, that's better for me.
Oopsies. All right, so who's got some ideas? What are some of the issues? Yeah.
There's a technical issue at place. So I have a question for you. Is there some laws protecting the twins in this case? Like, because I feel like twins should have the right to live with each other since they're siblings. When it comes to adoption, you know, how does that?
There may be. I'm not sure. I mean, I know of siblings that are separated all the time.
But do they know of each other? I feel like there should be like.
I don't know. I truly don't know.
Bad for these children.
Yeah, well, so let's be clear. Nobody's advocating for separating twins at birth. That is not what I am suggesting we do here. But if they have been studied, or if they have been separated, we do the research. So yes, aside from that concern, what are some of the issues associated with it? Yeah.
We talked about how maybe, like, obviously, like, remember causation doesn't equal correlation, but, like, with twins, I feel like a lot of stuff, they could just be chance. We're like, well, they're twins, so maybe
Yeah.
it's because they're twins.
Yeah, right? I mean, you find some spooky, correlation there, and you want to say, oh, it's because they're twins. When in reality, if you just take two people out on the street, maybe they have the same chance of, that's where, correlation relationship. That's additionally confounded by the fact there just aren't a whole bunch of separated identical twins, and so you've got small sample sizes. There. Yeah?
This is a random question, but if identical twins, like if two sets of identical twins get married and they have kids, are their kids genetically siblings? Yeah.
Hmm.
Yes. Same DNA.
Yeah, I mean, so genetically they would be, yeah, I mean, genetically they would be as similar as siblings. I don't know how to answer this. Yeah. Yeah, I mean,
No, like identical twins, identical girls, and they each have kids together. Yeah, like it's not identical twins having kids with the same one.
yeah. Yeah, no, I mean, I think, so, I mean, there's potentially little variations in that what's manifested from the mom and from the dad can be changed ever so slightly. But I don't think that would be any different than you would have just normal siblings. And so, if you can find a case of that ever happening, Send it to me.
There's a picture.
Is there?
That was around online for a couple years ago, and that exact scenario happened. So like 2 twin girls married 2 twin boys, and their kids look exactly the same, and they happen to have twins as well. And so like when you look at their kids, they look identical. But I didn't get to like research it. But
Yeah.
that's what it-
That's fascinating. Yes.
So there's an article about, I assume the same couple, they like dress the same on their wedding day.
Of course they did.
Everything, but it says that
So annoying.
their siblings are genetically the same, or there's children that are genetically the same as siblings would be.
Okay. So yeah, so I mean, I guess genetically, but then I guess it depends on what the definition of sibling is. But it's an interesting question. Yeah. That's wild. All right. Coming back to the question. What are some of the problems associated with it? What concerns might we have about drawing the conclusions? That was a half hand. Take a shot, whatever you're going to say.
Well, I can't remember the exact bias is called, but like I would assume, like similar to what she was saying, if an experimenter was expecting something, a correlation to happen because they're twins, and it's just by chance, I feel like there'd be a bias. So like a lot of the conclusions might not be completely correct because people just expect it to be the same as twins.
Yeah, confirmation bias, and so you're really digging down to find data that supports whatever your hypothesis or theory would be. Maybe there's also something that genetically makes you predisposed to having twins that's then being passed off to the twins that is affecting whatever these manifestations are, and thus are not a great representation for the rest of society. All right, we'll go ahead and move on. So, we can also think about temperament for individuals. This is the emotional reactivity and excitability, right? And so you may have heard temperament used in a colloquial sense. But in this case, it means essentially how volatile is somebody, how excitable is somebody. Can they have a deadpan affect, or are they really easy to work up in some capacity? So when we look at temperament in twins, identical twins tend to have more of an identical temperament. So what does that mean in terms of nature or nurture? So there is likely a substantial nature component. So your temperament, your affect, how excitable you are, how quick to anger you are, things like that, while not entirely genetic, does seem to have a substantial genetic component. We also find that temperament tends to stay pretty steady throughout life. So if you're impulsive as a child, you tend to be more impulsive as an adult. Has anybody ever heard of the marshmallow study? So those nodding your head, what is the marshmallow study?
There's a kid in the room, and they put a marshmallow, and they took a time, and they're like, you wait an hour, I'll give you 2 marshmallows, and they leave the room, and the kid either eats the marshmallow or they wait.
Yeah, so they'll put a marshmallow in front of a kid, and thankfully it's not an hour. It's just like 5 minutes, where they say, if you can, I'm going to run out and grab something. I'll be back in 5 minutes. If you eat this marshmallow, that's it. You get 1 marshmallow. But if you wait, I'm going to come back and give you a second marshmallow, so you get 2 marshmallows. All you have to do is wait 5 minutes. They ran that study, and then they followed these kids throughout their lives, and they found that those who waited for that second marshmallow were more likely to graduate college, more likely to become CEOs of their company, tend to be more successful by most metrics across the life. Now you can also see this, and it's not, again, anything I'm saying does not mean it's explaining all the variants. So if as a kid you only ate one marshmallow, you still have all the opportunities in the world to become successful. And CEO, yep?
But then there is another very, very extreme variable, because I saw a documentary on the marshmallow study. They gave the kids jumbo marshmallows, and it was 15 minutes. One of the kid, like, I laughed my ass off when I saw this, but when they took the marshmallow, they're like, oh, he waited, but then they looked at it. This kid ate inside the marshmallow.
And
So,
left
like,
it?
the exterior was still intact, but there was like a hole in the inside. I'm just
Now that's clever. Yeah.
That's what you call a genius right there.
Yeah, there are a lot of videos of this because they wanted to document it, and it's kind of funny. But you can see all these videos of these kids just dealing with the torment of waiting 5 minutes to not eat that marshmallow. But you can also do this, they've done this with adults, based off of parking habits. So those who back into parking spaces are more likely to be successful when you control for the type of car than are those who go nose first. Now, as a nose first guy, I hate to tell you that. I think also if you go back in, you're a psychopath. But it still does correlate.
It depends on how wanted you are.
How wanted you are? Maybe.
If you back in, you have a faster way about.
Well, I sleep easy at night. I'm not wanted, man. All right, so heritability refers to the degree to which differences among people can be attributable to genes. So how much of who you are you getting from your parents, essentially? So based off of data collected with twins in adoption studies, we can provide estimates of the amount of variance which can be explained by genes. An important misunderstanding or misinterpretation of this is that this means that a certain percent of the trait is explained by your genes. And that's not what that means. Rather, a percent of the variation in levels of expression of the gene can be explained by genes. I'll show you a graphic of that in just a second. So, the wrong way to interpret this would be that a single individual has whatever level X of trait Y, and that 60% of that trait is caused by genes. So that's not what this is saying. What it is saying is you have natural variability or variations, like we talked about at the beginning of class, between people. And so the entire variability, a certain percentage of this variability is explained by genes. Does that distinction make sense? Questions about that distinction? Cool. So as we've talked about, gene environment, or the genes and your environment interact and can affect how much of your gene is manifested. Right? And so, an example here, despite having very similar genetic makeups between North and South Koreans, malnourishment amongst North Koreans has led to their population being on average about 6 inches shorter. We can also think about your environment triggering or blocking your genetic expression. And that field is referred to as epigenetics. So things like food, your diet, you suffered abuse, these can all affect whether a certain gene is expressed, it's turned on, turned off, or the degree to which it manifests. So again, in addition, if there's anything you're taking away from this class beyond correlation does not imply causation, it's that it's almost never nature or never nurture. It's the interaction of the two. So here are examples of actual epigenetic effects. Mother's exposure to pollution could impact child's asthma susceptibility. Vitamin D can change DNA methylation, which influences placenta functioning. But it's not just while you're developing in your mom, it's father's diet, potentially, that can affect the offspring as well. So what your dad ate prior to conceiving you can affect your memory and learning ability as well. So lay off of mom. You can blame dad for some things that screwed up.
This program is brought to you by Everett University.
How can mice like these help us understand how one generation transfers behavioral traits to its descendants?
We of course can't use humans because it's just too complicated. We can't study multiple generations of humans, and we can't manipulate the process of humans to understand mechanism and causation. Mice provide the perfect model.
In fact, these mice have helped shed new light on the emerging field of epigenetics, which has profound implications on the way we might one day treat the effects of trauma.
It's been shown for over 100 years that we can take a mouse, expose it to a mild stressor, and pair that stressor with a sensory cue so that they will then avoid that sensory cue, whether it's a smell or a sound or a visual cue. And there is evidence in humans in metabolic cases such as the Dutch Underwinter or the Swedish famine, where there's been profound starvation in a generation, that somehow has changed the metabolic processes in subsequent generations. And that seems to be an epigenetic mechanism. And we were really interested in whether such processes may be going on in our model systems.
Now, Emory researchers Kerry Ressler and Brian Dias have shown that an experience linked with a smell can modify the architecture of the nervous systems in later generations. They have published their findings in Nature Neuroscience.
What we found in the study was that conditioning animals or training them to associate a particular smell with this type of food shock gives us descendant generations that are slightly more sensitive to this smell, and their brain devotes more real estate to processing the smell.
This is about 50 micron.
To our minds, we needed to figure out how this was actually occurring. And there are two real possibilities. One is biological transmission, which is very similar to cultural transmission and you learning from your parents or your grandparents as to how things are done. And the other possibility was an inheritance of these particular traits.
So they separated mice pups from their biological parents and allowed for them to be raised by unrelated mice that had not been conditioned to avoid certain smell.
Now what we found, shockingly, is that the neuroanatomical changes still persisted. That is, the brain still devotes more real estate to processing that cue that was salient to the ancestral generation.
This study adds.
Right, that's fairly remarkable. If you are having a hard time understanding what they were talking about, or what they did, they paired a smell, they gave a rat a smell, and then shocked it. Gave it smell, shocked it again. Created this association such that when it smelled that smell, it expected a shock. And then its offsprings, who were never exposed to that shock, had a similar reaction of fear to that smell. And they bring up the actual examples of famine, if you look back at those who experienced the Depression in the 20s here, 20s and 30s, those who really struggled with malnutrition had kids that were more susceptible to obesity after the fact. There was something about that malnutrition, that starvation, that led to a genetic expression to retain nutrients differently after the fact. You also see interesting manifestations of this. Men who go to war and come back are more likely to have kids that are boys than they are women, than if they were in the military but didn't go off to war. I'm running out of time here. I'm going to ignore that. And so this is one of the reasons that early experiences, early childhood, can be so important for the rest of a child's life, and even the kids that kid eventually sires. So for example, children who witness domestic violence or are themselves abused have higher levels of adrenaline and cortisol later in life. So if, God forbid, any of y'all had these sorts of experiences, you may be more susceptible to anxiety later in life. Part of that is psychological, but other parts of it are physiological. Similarly, children who are severely neglected are at very high risk of developing emotional, behavioral, social, and intellectual disabilities. So there are a couple extreme examples of child neglect. It's not all bad, however. Learning a language early in life makes it much more easy to learn languages, subsequent languages later on in life. Another example you all may have heard before is that children with a musical background are more likely to be good at math. Also, character-based languages are more likely to help children develop math skills. So character-based languages would be like Chinese. And finally, this is one of the explanations for why things like poverty can be so hard to escape, right? Poverty frequently, but not always, leads to malnutrition, which can negatively impact brain development and intelligence. And this is one of the ideas, one of the foundations behind concepts like free or reduced price lunches for school kids, because we want to help combat some of that malnourishment, which has long-lasting effects into adulthood. And yeah, we'll call that good. All right, I will see y'all on Thursday.